class? Tetracycline. Chemistry means what and all you will write? Structure, connectivities, and you will explain, isn't it? The numbering starts from which group? Ketone group. What is the second question? Amide group. What is the third question? Enolic OH. What is that? Enolic OH. What do you mean by tautomericism? Tautomericism means the hydroxyl group, and you have studied aldo, keto, enol, tautomericism, isn't it? Aldehyde and ketone can be interchanged. That means the lone pair of electrons in the oxygen can be interchanged as a double bond. So here the hydroxyl group, if you take the double bond and if you include the pair of electrons over the oxygen, it will be ketonic form. If there is a deprotonation and if the double bond is going as an electron, then you will get keto-enol tautomericism. Tautomericism means similar structure which deviates in one particular bond. That means COH can be converted into C double bond. So here, in case of SAR, that structure activity relationship of tetracyclines, the first point is the linearly fused tetracycline nucleus. That is 4 nucleus required for antibiotic activity. What is the first point? The tetracycline nucleus is very important. What is the first point? The tetracycline nucleus. The 4 nucleus is important. Right now. And the second point is, if you convert the carboxamide group, that is in the second question, you have a carboxamide group. If you change here, instead of this, if you do not have a carbonyl connectivity, the activity will be lost. So essential groups are, so you can simply remember that in the structure, what are the things repeatedly found? Those are all essential fragments. Those are all what? Essential fragments. So instead of carboxamide, if you do any alteration, then there will be a loss of activity. So that is the second point. Second point is what? Carboxamide moiety is needed. Have you written? Then third point is the keto-enol tautomericism. The keto-enol tautomericism is between second and third carbon. So that is very important for biological activity. And in the fourth point, any modification of C3, that is if you do a esterification OC2H5, there will be no activity. So hydroxyl group is essential. Why hydroxyl group is essential is, in case of drug design we have seen like during the transportation there are 2 parameters needed. One is hydrophilic and other one is lipophilic. So they have to reach the receptor. So this type of OH group is essential. So third question, OH is essential. And then fourth question, you should have dimethyl amino group. That dimethyl amino group should be in the natural form. That is, it should be in alpha configuration. It should be in which configuration? Alpha configuration. In case of epitetracyclines, if it get converted, the activity will be lost. That means if you change a configuration from this side to that side, there will be a less fold in activity. Then